Okay, so we're going to do lesson 9, mineral identification. The last lesson we looked at rocks, and today we're going to dive into minerals. Have you ever wondered what is the difference between the two? If I put a rock and a mineral on the table, it would be pretty hard to figure out which one it was just by looking at them. So when scientists are figuring out which is which, they ask 4 basic questions. Number 1, is it organic? Which means, is it made of living things or the remains of plants and animals? Many sedimentary rocks are formed from living things, like coal, which is formed from the remains of plants. These are rocks, like igneous and metamorphic. They are not created from living things, though. So we need more questions to determine a rock versus a mineral. Number 2, did the substance occur naturally? Nothing that is made man-made can be a mineral, and neither can it be a rock. An example would be man-made metals like brass or steel. Number 3, is the substance a solid with a crystalline structure? That means, do crystals form its shape? Obsidian, which is an igneous rock, is not made of living things, and it is naturally formed substance, but it does not have a regularly repeating crystalline structure, so it could not be a mineral. Number 4, does the substance have a consistent chemical composition? What a lot of words starting with C. Minerals are made of patterns of different substances. For example, fluorite is a mineral that is made of 1 calcium ion for every 2 fluoride ions. Rocks do not have this consistent pattern, and it can have a variety of substances in their makeup that make many different rocks. Now that we know how to tell the difference between rocks and minerals, let's look a little deeper at some types of minerals. All minerals are classified into 2 main groups based on what they are made of. Silicate materials are minerals that contain a combination of silicon. Silicon is Si on the periodic table of elements, and oxygen, which is O on the periodic table of elements. Feldspar and quartz are the most common silicate materials and make up 50% of the Earth's crust alone. Silicate materials in general make up 96% of the Earth's crust. Non-silicate materials do not contain silicon or oxygen in their chemical composition. These minerals only make up about 4% of the Earth's crust and can be broken down into 6 subgroups based on what they are composed of: carbonites, halides, native elements, oxides, sulfates, and sulfides. When fluorite is found in a rock, all the crystals that make it up are in the shapes of cubes. This is how the mineral naturally grows. Fluorite is a very soft mineral that can be easily scratched with your fingernail. Fluorite has been used to carve sculptures. It is found in many different colors, but the most common colors are purple, green, and translucent yellow. One of the most interesting things about fluorite is that it is fluorescent. This means that when you shine an ultraviolet light or a black light on fluorite, it glows. Most commonly, it glows a bluish color, but has been known to glow white or cream as well. Fluorite has many uses, including lenses for telescopes, microscopes, and cameras. Also, the non-stick cooking surface called Teflon is created from using fluorine, which is created from fluorite. Do you have any Teflon cookware in your house? And this is what it looks like. Calcite is a rock-forming mineral that is extremely common and found all over the world within sedimentary, metamorphic, and igneous rocks. Calcite is one of the main components of both limestone and marble. It is one of the most widely used minerals in the world and has more uses than any other mineral. Construction uses calcite in the form of limestone and marble to produce cement. Antacids that people use to neutralize their stomach acids are made up of calcite as well. I know Chase takes antacids. Another interesting feature of calcite is the ability to bend light. When calcite is transparent, which means it's clear or see-through, it can bend light in such a way that it will create a double image of anything viewed through the mineral. This is called double refraction and takes place because light rays are split into two parts as they enter the crystal. And this is your calcite right here. Quartz is another very abundant material on the earth. It comes in many different colors, including pink. That one is called rose quartz. Yellow is called citrine. Purple is called amethyst. White is called milky quartz. And brown and gray is called smoky quartz. It is found in a lot of igneous, metamorphic, and sedimentary rocks, and is very resistant to weather erosion due to its hardness. It is the dominant mineral on mountaintops and primarily makes up sand on beaches, rivers, and in deserts. Its hardness and ability to shine make it very desirable as a gemstone in jewelry. Quartz sand is an excellent abrasive. That means a polishing or a cleaning through hard rubbing. Used in sandblasting, cleaners, and grip for sanding materials. But one of its most unique features is its ability to vibrate at different frequencies. It is so precise that quartz is used to make extremely accurate timekeeping instruments. Today, quartz is used in watches, clocks, radios, computers, and cell phones for this exact purpose. And this is the quartz right here. It looks like that's probably the milky quartz, the one that's white. Native copper is both an element and a mineral, and is a naturally occurring metal, unlike brass. Copper is usually a reddish-brown color, but it will turn green when it's exposed to the air. The green is basically like a rust that forms on the metal from exposure to oxygen that is in the air. Copper was one of the first metals ever used by humans to make coins and tools. Copper absorbs heat very easily, and today is often used to make pots and pans for cooking. Copper is also an important part of vehicle motors, but the largest use of copper is in construction. It is often used in electrical wires because electricity flows through it easily. The Statue of Liberty in New York City is actually made of copper. Have you ever noticed its green color? And this is the copper right here. And I would suggest that you take a look at the Statue of Liberty, because when you look at it, you think it's green and you don't really think of it being made of copper. So that's kind of interesting. Pyrite is also known as fool's gold. It is a brassy yellow mineral that has been mistaken for gold in the past, hence its name. Pyrite is often associated with gold, however, and the two often form together. In some deposits of pyrite, there is enough gold within the area that makes it worth mining and removing both. But how do you tell the difference between gold and pyrite? They test them. Pyrite is very brittle and will fracture. Gold is very soft and will bend or dent if tapped with a pinhead. When scraped, gold will leave a yellow streak. But if you scrape pyrite, which is usually used in a gemstone, it will turn greenish black. It also sparks when it hits against steel, so it was used in early flintlock firearms. This is the pyrite right here. Magnetite is a mineral that contains the highest iron content, 72%, and it is often found within igneous, metamorphic, and sedimentary rocks. Magnetite is very easy to identify because it is the most magnetic mineral on Earth, and it is attracted to a common magnet. There are some forms of magnetite that can attract small pieces of iron and other magnetic objects. This form of magnetite is called lodestone. Pieces of lodestone suspended on a string were the earliest forms of compasses used in China in 300 BC. And this is the magnetite right there. So now it's time to open up your notebooks and do today's lesson. Make sure when you complete today's lesson, you upload it to Google Classroom so that I can take a look at it. Thank you. Have a good day.